So let's look at the division of polynomials. And in this lesson, we're going to divide a polynomial function by using both long division and a new method called synthetic division. As well, take the final solutions and write them in these two forms as indicated there. But before we actually do, let's do a little bit of a review of long division. And if you remember long division, and we had this number, 1537 divided by 12. When we did long division with that number, what we did is we took the number 12 and we divided it into 1537. And what the first thing we looked for is how many times does 12 divide in to 15? And 12 divides into 15 once, so we would go along here and we'd write a 1 at the top. And then we did 1 times 12 is 12, subtract, and bring down the solution 3, as well as bring down that next number, 33. And again, now we were figuring out how many times did 12 divide into 33, and 12 goes into 33 twice, leaving us, when we multiply it to 24, again, we're going to subtract, giving us 9, bring down the 7, giving us 97, and we figure out how many times does 12 go into 97. Well, if we put a 6 up here, 12 times 6 is 96, and in the end we'd have a 1. And sometimes you probably wrote it like this, remainder 1. Now, this is important because each of these pieces has a name. Our solution is our quotient. When we do the division, what we get is the quotient. Obviously, what's left over is our remainder. What we are dividing by is called the divisor. And what gets divided is the dividend. And we are going to use these same techniques when we divide polynomial expressions. The difference is, though, when we divide a polynomial p of x by d of x, that's like saying our dividend is p of x over our divisor d of x, doing that division. We're going to write our final answer in these two forms. Polynomial equals the divisor multiplied by, and the q here, or q of x, is actually the quotient, and r is the remainder if it exists. So we can write it like this as an equation without fractions, or we can consider it as an actual equation with fractions, that p of x over d of x is equal to the quotient plus the remainder over the dividend. And these forms we're going to look at as we do some examples. But first, let's do some long division of polynomials. And again, we use very similar techniques. We're going to take our divisor. This time the divisor is a binomial, and we're going to divide it by our polynomial, or our dividend in this case, of x cubed plus 7x squared, just the polynomial that is written there, plus 14x plus 8. So we start out the same way. And now we're going to do the division, or the long division. Now this time, though, what we're looking for is we're trying to figure out how many times just x divides evenly into x cubed. We're only going to concern ourselves with those terms. That's our long division. Now, if we can't remember, we'll go over here and say x cubed divided by x gives us x squared, and that's the term that we're going to write above like we did before. We're going to write x squared up above. And notice how the squared terms are all lined up. So much like we did with long division, what divides into goes on top. Now we do a multiplication, but this time we multiply our top term by the entire binomial. We multiply each term in the binomial by x squared. So x squared times x is x cubed. X squared times 1 is plus x squared. And like we did before, we're going to subtract those values. So x squared subtracted from 7x squared will leave us 6x squared. And this is what's important for polynomial division. X cubed minus x cubed is going to leave us with a 0 x cubed. And I'm going to write it in the first time, but that's important that we have a 0 x cubed. Well, now, just like in regular long division, we bring down the next term and we go again. This time we want to see how many times does x divide evenly into 6x squared. And again, you can do these calculations in your head. If you need to, we'll do a calculation over here. 6x squared divided by x is 6x. And that means we're going to write 6x up top here, plus 6x. Well, again, we're going to do our multiplication. 6x multiplied by both of these terms, and that's going to get written down here. So 6x times x is 6x squared, and 6x times 1 is plus 6x, and now we can subtract. 14x minus 6x is 8x, and again we have that 0x squared term. I'm not going to write it in this time, and one more time we bring down our number, and once again we do one more check. How many times will 8x get divided by x? And of course, we'll just have an 8 right here. And if we do our multiplication, we get 8x plus 8, and final answer here of 0. Now that allows us to do the long division. But now we want to write this solution in our two forms. Before we write the solution, we want to make sure we know what everything is. Here is our d, our divisor. Here is our quotient. Our polynomial is underneath. And in this case, here is our remainder. So if we wanted to write this in our two forms, we could start with p of x is equal to our divisor, x plus 1, multiplied by the quotient, x squared plus 6x plus 8, and in this case we have no remainder, so there is one of our forms. The other form is where we write p of x over d of x. And this time I'm going to write out the entire polynomial. We have our original polynomial of x cubed plus 7x squared plus 14x plus 8. When we divide all of that by x plus 1, we got a solution, a quotient of x squared plus 6x plus 8 with no remainder. So there's the two forms. Sometimes you'll see it with the p of x in the form. Sometimes you'll see the actual polynomial in that form as well. And that's long division. Now, long division, though, is long. And there is an alternative method, a much quicker and easier method called synthetic division. And synthetic division is a fast way of doing the long division because it really reduces the calculations. It reduces the amount of calculations you have to do. So we're going to do the exact same question again, this time with synthetic division. And synthetic division is quite different because it only deals with the coefficients. So we're going to start by writing out the coefficients in front of each of the terms in the polynomial. First coefficient would be a 1, then we have a 7, then a 14, and then an 8. And they're all positive, so we're just going to leave them as all positive terms, just like that. Now, what we're going to do the synthetic division with is this divisor, x plus 1. And what we really want to think about is what would the 0 be if it was x plus 1? Remember, we've looked at zeros. The 0 would be -1, and that's the value we're going to use for our synthetic division. Now, instead of doing a division sign, we're actually going to do kind of like an upside down division sign, and we're going to put the divisor 0, the -1, outside that synthetic division sign. And with synthetic division, it's actually a very, very simple process, and it always starts the same way. First, the number in front, the first coefficient, always comes down. And that value is what we're going to use to, instead of divide like we did in long division, multiply. So for synthetic division, we're going to multiply this number by that number. We're going to multiply those two values together. And when we do that, we'll get -1. Now, with long division, we subtracted. Synthetic division, we add. That's going to leave us with +6, and I'm going to put the positive to make it very clear. And now we go again. 6 multiplied by -1 will be -8. Add again, and we'll get a +8. One more time, 8 times -1 is -8, and that's going to leave us with a 0. Now, the coefficients have actually changed, and this is what makes synthetic division so powerful. What has happened is our original polynomial was an x cubed. We have divided this polynomial, and so the new solution, the quotient, will be an x squared term. This original x cubed term becomes x squared. And that applies to all of these values. And all of these values are some x with an exponent. 7 is 7x squared. So when we get our 6 here, instead of an x squared, it drops 1 down and becomes x. +8 is in the x to the 1 column, so we'll just have a +8. And I'm going to write this in to make it clear, of x to the 0. And the last column, this last value down here, always tells us the remainder. This is the remainder of the synthetic division. And notice that this solution, this quotient, probably better to write it as x squared plus 6x plus 8, is the exact same quotient that we got when we did the long division. So synthetic division is a faster way to get to a quotient, and also a faster way to get to a remainder. Let's try another one. Only this time we're going to use 2x plus 1 as our divisor. Again, think of the 0. The 0 in this case would be -1/2, and that -1/2 will be the number we write outside the synthetic division symbol. All the coefficients get written in just like so. And now we do our synthetic division as we did before. Bring down the first term, giving us a 2, and that number multiplied by the number outside, 2 times 1/2, is -1, and now we add. 3 minus 1 is 2. 2 times 1/2 again, or -1/2, is -1. We now have -6. -6 times -1/2 will give us 3, and we get this final answer, 5. That last number is our remainder, and that tells us then that our solution, our quotient, is 2x. Remember, it drops down 1 degree, was cubed, so 2x squared plus 2x minus 6. And we may have to take that and write it in the necessary form, but we have to keep in mind that our remainder is 5. So synthetic division is just a quick way to get to a quotient, And from that quotient, we may have to write the solution in a variety of ways. There is one note that's very, very important though. In order to do either synthetic or long division, all the descending powers of a polynomial must be present. So we need an x cubed, an x squared, an x, etc. If any power is missing from the polynomial, we consider it as a coefficient of 0. What does that mean? Let's use it in this example. Notice in this question, we go from an x cubed to an x. We are missing an x squared term. So what we do is consider it a 0x squared in our polynomial, because that then allows us to do the proper synthetic division. The first coefficient is 4. The second coefficient is 0. Third one is 7. Fourth one is -5. And we are dividing by 3. You can see how quickly we can find a coefficient with synthetic division. We bring down the 4. 4 times 3 is 12. Again, we're always adding. That gives us 12. 12 times 3 is 36. Doesn't matter if the numbers get big, and these numbers are going to get a little bit big. 36 plus 7 is 43. 43 times 3 is 129. And -5 plus 129 is 124. Now this will allow us to find the quotient of 4x squared plus 12x plus 43, and also tell us that the remainder is 124. And from that information, we may have to write that polynomial in a necessary form. We may have to use the remainder, but synthetic division, long division, very important skills that we're going to use throughout this course and do more in class.